Welcome to our lesson on functions with student Aryan, grade 8 student doing grade 11 mathematics. Share the passion of learning, stay ahead of competition. That is the gift of education. You can join my classes and learn more. Send an email on the address given and share the passion of learning. In this video, we will talk about functions and look into some important characteristics including increasing decreasing interval and then discuss transformations with Aryan. Enjoy the lesson.
Yeah, functions. Yeah, just like the introduction.
Okay, so Aryan, uh, let us try to understand what are functions and what are their characteristics. Before that, I'd like you to share with me what have you done at school so that we could build on that.
Yeah, so in school we just went over like basically how to find like the transformations for a function, the domain and range, the when the function has a positive rate of change and when it has a negative rate of change. Yeah. Um we just went over like a Desmos activity where like we went over like transforming functions and like the basics of that.
Okay.
Yeah. Yeah, let me yeah.
Yeah, sure. Let's go through it.
Yeah, so yeah, I just already did this because this was a class assignment, and
Mhm.
this like it's like basic. It's just about basic transformations. So like for
Correct.
this one, it's just you're going down 5 and then you're going to the right 3.
Translations, vertical and horizontal. Yes.
Yeah, and then like finding different equations from like the
Given a
parent.
function, right? So first function, how do you get the second function? Correct.
Yeah,
Next. So that's a vertical stretch by a factor of 2, you mean, right?
2. Yeah,
Yeah, because doubled up, right? In this case, seems to be a reflection, right? That's what you're
yeah,
trying to
yeah,
show. Good.
yeah.
Yes.
Yeah, yeah. You can see my answer over there.
Yeah, your answer is a minus of correct. Correct.
Yeah, and then this is just like another like
Vertically compressed by a factor of
yeah
2.
1/2. Yeah, and this is just you're going
Translated
to the right
4
form.
units
Yeah,
to the right. Correct.
yeah,
Translated 4 units down. Correct.
yeah. And this is just you're going to the left 4 and then you're going
Combination
down
of,
3.
yeah,
Yeah,
left 4 units, 3 down.
yeah,
Similar ways you've done. That's good. That's good. Yeah, yeah. So combination of stretches with translations. Correct.
yeah, and then the reflection over the x-axis.
Perfect. Minus 2. Mm. Okay.
Yeah, that's basically just it.
Okay. So let me uh, teach you functions starting from where you are, right? Let me just have a whiteboard to begin with. Okay. So we'll talk about functions. Domain range.
Okay.
Increasing degree.
Yeah,
And I think transformations.
yeah, okay.
That should cover it all for what you have learned and what you are going to learn in the next class. Is that okay?
Yeah,
Correct.
basically all that. Yeah, and like the
Yeah,
different types of functions.
correct. So when we say functions, first thing we talk about is relations and functions, right?
Yeah.
What is the difference? Can you tell me the difference?
Oh, okay. Yeah, so a function is when like the relation shows the relationship between the input and output, where a
Correct.
function just has one output for just like one input.
Correct. So all functions are basically relations. All functions are relations. That's very important to understand. Second is that in functions, every input
Has one, yeah, only one output for that.
Has exactly one output. So when we say that, it really means that if we have this, I'll show you with the help of a mapping diagram, that if we have something here, then that could be a function, correct? Arrow showing that this is your input and that is your output, correct?
Yeah.
Now, if we have another element here, it could go to one element in the output domain also. But everything on the input side uniquely is associated with only one thing on the outside. So in functions, we have two types of functions, which is one-to-one
Yeah.
and many-to-one. So one-to-one or many-to-one relations. Is that clear to you?
Yeah.
And if we have a graph, we say they pass vertical line test.
Okay.
Okay. So this is clear to you, right? Let me just erase this, move forward. So when I say vertical line test, I'm trying to say that, let us say we'll make a graph here of a parabola, correct?
Yeah.
So in this parabola, if I draw a vertical line, then it only passes through one point. Do you see that?
Yeah.
So that is a function. So this is the function. On the other hand, if I have a circle, for example, so let me draw another case here. And if I draw a circle, for example, right? In that case, if I have a vertical line, it crosses at 2 points, right? So
Yeah.
this is not a function, right? How did we test? We tested with the help of vertical line test.
Yeah.
Now we could also test it out from the equation point of view. For example, circle equation, you remember? The
Yeah.
equation of a circle is x squared plus y squared equals to r squared, right?
Yeah.
If you isolate y, what will you get? Well, y square will be r square minus x square, and y will be square root of r square minus x square. And whenever you do square root, you do plus and minus.
Yeah.
So that means for the given input x, we could have plus and minus means two outputs, correct?
Yeah.
So that is what we are saying. For one input x, we could have output which could be these two values. And therefore, it is not a function, correct? So
Yeah.
one of the easy ways to figure out whether a given equation is a function or not is to look at y power. If the y power is even, it is not a function. You get the idea.
Yeah.
So that is a good way of checking. So that is basics about functions. And now let's talk about domain and range.
Okay.
So I'll draw some parent functions so that we could discuss domain and range of all these parent functions one by one, right? So
Yeah.
let me make it smaller actually. So we'll draw a couple of functions here and we can discuss their domain range. That'll be better, it'll be faster. So that is my coordinate plane, rough sketches, which are very meaningful for us, right? That's the whole idea. So, okay. So you know straight line is a function, correct?
Yeah.
You know parabola is a function, right? You know
Yeah.
cubic function, right? You know the absolute value function, correct? You know the reciprocal function, right? You know the sinusoidal function,
Yeah.
correct? So these are different functions. One of the very important function is the square root function, right? And we'll add some more exponential function, for example. Is that clear to you? So let's talk about these functions. So now, getting to the very first one, which is linear function, what is the domain?
It's just
Domain
negative infinity. Yeah.
x
Infinity.
belongs to real numbers. And what is the range? range
Same
is
thing.
also y belongs to real numbers. In set form, we put them in curly brackets as I'm going to do here. Is that okay now? So that
Yeah.
is in set form. Okay. As far as the function shown here, which is the parabola, if I identify the turning point as, let us say, -2, -3, in that case, can you tell me what is the domain and range for this function?
Yeah. Your domain is just gonna be all real numbers, and then your range is gonna be from -3 to infinity.
Now, important, -3 is included, so that will come in the square
Yeah.
bracket. So this is another notation, interval notation, which we use. Right. Polynomial, let's say this is x cube, has domain and range which is from negative infinity to positive infinity, and so it has no restrictions. Correct? For a cubic functions, no restrictions. Correct? The absolute
Yeah.
function, let us say this particular point here is at 2, 0. In that case, we say that the domain of this particular function has no restriction. It is from minus infinity to plus infinity. However, the range of this function has a restriction. It is from 0 to infinity. Is it okay? 0 is including, so I'm putting it in square brackets. Perfect. Now let's talk about these functions. We have a reciprocal function, let us say 1 over x. Can you tell me what is the domain of this function?
Yeah. The domain of that function is just negative infinity to infinity, except when x is equal to 0.
So x belongs to real numbers, but x is not equal to 0. That's a good way of writing this domain. Similarly, we could write the range of this function as y belongs to real numbers, where y is not equal to 0. Is that clear to you?
Yeah.
Okay. Now, the other function is a sinusoidal function, which I have tried to draw here. So we have this as +1, this as -1. Can you tell me domain and range of sin x?
Yeah. The domain is just going to be all real numbers,
Yes.
but your range is going to be from -1 to 1.
Perfect. Now we have another function, which is square root function, square root of x. Can you tell me domain and range for this function?
Yeah, it's just your range is just from 0 to infinity, and the same for your domain.
You are right. For the exponential function, what do you say?
Yeah.
Domain and range.
All real numbers for the domain, and then from at like 0 to infinity for your.
But this time, 0 is not
Yeah,
included.
that's why. Yeah.
So that is how you give domain range of your functions. Of course, when you transform, this domain range get transformed, which we'll look into later. Is it okay? Now,
Okay.
let me clear this and get to increasing, decreasing interval.
Okay.
Okay, so I will take a function. Let me just draw one, which is showing the path of a particle, let us say, and let's say it goes like this, this. Now,
Okay.
this particular function, does it have any decreasing interval?
Yeah. Um.
No decreasing
No.
interval.
No. 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 It's always increasing.
So this function is always increasing, not decreasing, right?
Yeah.
What does this portion show, which is kind of constant?
Yeah.
So we have this portion which is increasing. This is also increasing, and that is a constant, right? Not neither decreasing nor increasing. Correct. Now, when we talk
Yeah.
about increasing and decreasing intervals, one thing is very important is how fast, rate of change.
Yeah.
Now, this portion has a constant rate of change.
Yeah.
And this portion has a different rate of change, right? So you will notice
that here the rate of change is increasing. So this is increasing rate of change. Do you understand?
Yeah.
So this is another very important parameter to look at a function when we talk about increasing and decreasing interval. Is that okay? Now,
Yeah.
here is a question for you. Now, this particular function, let us say this is your minimum at -2. These are my intervals at -3 and let us say +3. Okay. Now tell me, what is the decreasing interval?
From negative infinity to -3, or like
Decreasing
yeah.
interval.
Oh yeah, from yeah, I think it's just negative infinity to 0. Yeah.
0. Because it
Yeah.
is decreasing till this particular point, and of course, increasing interval is from
0 to infinity.
correct. Now here we also see that the function is also positive or negative. So when is this function greater than 0? Positive. Can you tell me?
Yeah. So yeah, when f of x is greater than 0, then you're yeah, it's just yeah. That's well, yeah.
Both. It is
Yeah.
positive means above the x-axis, correct?
Yeah, that's why I was a little like hesitant. Like
Correct.
yeah.
This is very important to understand these parameters. When is f of x less than 0? That means it is negative, right? So
Yeah.
that is from -3 to 3, right? So it is negative. Is that clear to you? So
Yeah.
here we learn that a function could be positive, could be negative, increasing or decreasing. Correct.
Yeah.
Now here is another set of questions for you. We have a function which is increasing like this, decreasing, and then like this. Okay. Now, in this particular case, can you tell me where is within the domain? Let us say we consider the domain only from, let's say this is -10 to, let us say this as 10. Is it okay?
Yeah. Yeah.
So I
That's fine.
want you to tell me where is, and let's say this point here is at -4, and this point here is at let's say 2, right? This this point here is at 3. Okay.
Yeah.
Now you tell me from the given diagram, let's say this is 5. Okay, that's great. Where is it decreasing?
Yeah. From 2 to wait, it's a little
This point is 3.
yeah, that's what I'm gonna say.
So from 2 to 3, right?
Oh yeah. That's why I kind of I'll yeah,
So it is decreasing in the interval from 2 to
2 to
3,
3.
correct? So when is it constant?
From -4 to 2.
2. Right. Now you need to tell me where is it, where is the rate of change, maximum rate of change?
From 3 to infinity, or
It is between 2 to 3 because you see how steeply it goes down?
yeah, that's why yeah.
Within the interval, we are talking about from -10 to 10, right? So I'm restricting ourselves to within this interval from -10 to 10. We find that the maximum rate of change is between 2 to 3. Now, you should not think when we say maximum rate of change, it could be positive or negative. Does it make sense to you?
Yeah.
Correct? It could be positive or a negative. Now, the next question, very important, is where do we have a constant rate of change?
It's just it's yeah, we have to we're constant from -4 to like that
Let's say
that
this
point.
is
Oh
our
yeah.
domain, we are starting from -10. Then also from -4 to 2. Do you see that? Horizontal line is also a
Yeah.
constant rate of change. It is not changing, but it is 0 rate of change. Do you understand? It's a number.
Yeah.
Similarly, the rate of change here is the slope of the line, correct? which is also a constant rate of change, correct?
Yeah.
This is non-linear, and therefore the rate of change is changing all the time. Is that clear to you?
Yeah.
Now, the question for you. You need to sketch a graph which is decreasing with increasing rate of change.
Yeah.
Yeah. How will you sketch this? Explain. I need you to sketch a graph which is actually decreasing, means coming down, but the rate of change is increasing.
Can I annotate?
Yeah.
Yeah, 1 second. Like, would that just be it? Because like you're still
Yeah.
increasing.
Yeah,
Okay.
it is decreasing. It is like you're right. So you've done just the right thing. This is the right option. How do I see? We are saying decreasing and increasing rate of change. It is like coming down from a slide. Do you see that slide?
Yeah.
So if you sit here and then your velocity increases, right? You go faster and faster. So this is the graph which is decreasing and increasing rate of change. Perfect. If I want to do a graph which is increasing,
Yeah.
but decreasing rate of change, how will I graph it?
Yeah.
Tell me.
Increasing but decreasing. Okay.
When you throw a ball, it goes like this. Do you see it is
Oh,
increasing?
okay.
But
Yeah.
the velocity is decreasing. Do you see that? Correct?
Yeah. Yeah.
If you look at it, you will see that at this point, rate of change is the slope. When we say rate of change, it is the slope, right? And the slope is decreasing. You see that? Slope is
Yeah.
positive, very high positive, less positive, and almost zero, right? Almost zero here. So
Yeah.
this is decreasing rate of change. And therefore, now we could now sketch graphs with given description, right? Constant rate of change, no change at all, decreasing in rate of change, and all those things. Now that is kind of important to sketch the graph and also describe the graph at times, right? Especially distance and position graphs, for example, displacement and velocity, displacement and time
Yeah.
graph. Those graphs you could explain using these terms, correct?
Yeah.
Last question is about the transformations.
Yeah.
So I will write a general function here. Let us say general transformation of a function f of x is given to us. Let me just write, okay, let me do it like this. We write a function g of x as a transform function for f of x. In general, I can say g of x is f of, let me write like this, k x minus p plus q, right? So that is the general equation for transformation where a and q refer to vertical, correct?
Yeah.
Vertical. Where q is basically translation.
Yeah.
And a is reflection, stretch, or compression, correct?
Yeah.
Vertical. This is all vertical. On the other hand, the inside terms which we talk about are all horizontal. You understand?
Yeah. Yeah.
Where k is reflection. So when we say reflection, it is on y-axis. Do you see that?
Yeah.
Or stretch or compression, correct? As far as p is concerned, it is a translation, right? So inside terms are translations left or right. Now, let me take up example and then we will see how do we explain this. I will take square root
Yeah.
function as my example. So I'm sketching square root function, which is right there. So we are
Okay.
saying square root of x. Basically, I could actually give some values and say at 0 it is 0, 1, 1, and at 4 square root is 2, 9 square root is 3, correct? So
Okay.
I have these some points on my graph 0, 0, 1, 1, and then at 4 I have, let's say, 2 and 9 somewhere there we have 3, right? So these
Yeah.
are my points which are 3, 2, and 1, correct?
Yeah.
Right. Now tell me, if I have a function whose equation is 2 times square root of x minus, let's say, minus 1, and we have minus 3. How will I sketch this?
So basically, it's a vertical stretch by 2, and
Correct?
then you're going to your right by 1 and down 3. So you're just gonna shift it to the right 1, and then you're gonna go back down 3, and then you're gonna like stretch it by 2.
Okay. So what we will really follow here is that if we have coordinate points, let us say x, y, correct?
Yeah.
Then how will the transform points change? We call them image points. Can you tell me what will be the mapping for the image points in this case? The x values will
Yeah.
get translated 1 unit to the right. So the x
Okay.
values will be x plus 1, and the y values will get multiplied
Yeah.
by 2, and then we'll take away 3. Do you see that?
Yeah. Yeah.
So that will give you these points. And once you plot these points, you can actually sketch a graph directly also. So if I add 1 to 0, I get 1 here. 2 times and minus 3 will be my first point. And second will be 2, and 2 times minus 1. And here 4 plus 1 is 5. And 2 times 2, 4, 4 plus 1 plus 1. 9
Yeah.
plus 1 is 10. 3 times 2 is 6. 6 minus 3 is 3. So if I plot these points, then I could actually change it, right? This is one way
Yeah.
of doing it. Just getting image points. Is that clear?
Yeah. Yeah.
Second, we could do with steps, right? So let me show you steps. So when I say steps, we'll go with step number 1, which is stretching by a factor of 2. 0 times anything is 0, 1 times 2 is 2, 3 times 2, 2 times 2 is 4. So we have a graph which will be kind of like this. Do you see that?
Yeah.
Now, to this graph, I will do 1 unit right and 3 units down. So I could go 1 unit right. So from here, 1 unit right, from here, 1 unit right, and from here, 1 unit right. I have a graph which is parallel to my previous, and I got this one. Is that clear to you?
Yeah.
And then I will go the final step, which is 3 down. So I'll go 3 down from here, which is, let us say here, 1, and then the next point 3 down. So it was at 2, it'll go 1 more down here, and then 3 down somewhere there. And we have the third graph, which is the final graph, and that will be represented by the points given here, correct? Starting with this point, which is at 1 minus 3, correct?
Yeah.
So we can plot all the points and get it direct, or we could do step-by-step transformations if required. So always what you do is, whenever you sketch a transform function, you do multiplication. That means stretch or compression or reflection, right? Followed by translations.
Yeah. Yeah.
So these are the steps involved when you are trying to sketch a function, which is a transform function from the
Okay.
original. Does it make sense to you?
Yeah, I understand.
Great. So we'll end the class here, and I'd like you to summarize our learnings today about the functions.
Yeah.
Yes, Aryan.
Yeah. So in today's class, we looked at graphing equations and finding their domain and range, and basically using the parent function as like a guide to like your transform function. So like transforming whatever function you have. So like from the parent function to get to your parent function.
Perfect. And we also saw the increasing or decreasing.
Yeah.
Also increasing and decreasing rate. Rate of change of increasing and decreasing sometimes becomes very confusing. So that should be looked into more in more details, right? Practice some questions based on that also, Aryan. Okay. So we'll end here. Okay then. Thank you.
Okay. Thank you very much.